All right. So today we'll take a look at subsetting. And subsetting is kind of the idea of, you've got this big, a bunch of values either in a vector or in a matrix or in a data frame. And you want to kind of just select certain things. You don't want the whole thing. And that's what subsetting is. And I think I saw a question on CampusWire. I see a lot of good discussion on CampusWire, so that's good. And thank you to everybody who's participating there. And if you're intimidated to participate, don't feel intimidated. Just say something, and you'll get credit for at least chiming into the conversation. So yeah, so don't worry. Okay. We'll just get started, and we'll start talking about subsetting atomic vectors. This is kind of the simplest scenario here, and we'll see how far we get. Last lecture, I didn't get through the whole thing. I don't expect to get through all of my slides today. I might just record like a short little supplemental 10-minute video for the slides I don't make it through at the end, but we'll make sure you do that. Okay. Before I get started, let me go ahead and give you your first view quiz answer for today. So week 1 Friday, your first view quiz answer is the letter B. The letter B as in bear is your first view quiz answer for week 1 Friday, B. Okay, so jot that down, and we'll move on. Okay, so here I've got a simple vector x. X is 4 elements, 2.1, 4.2, 3.3, and 5.4. And these are intentionally not in order from least to greatest. And however, the position after the decimal is in order. So I got 0.1 for the first element, 0.2 for the second element, 0.3 for the third element, and 0.4 for the fourth element. So you can kind of see what's happening without having to memorize exactly what order these things are in. Okay, and there's a few ways you can kind of subset a vector. You can use integers, positive and negative, and you can also do logical things and character things. So let's just take a look. Okay, so I think you guys are already familiar with this, but you can just use a single square bracket, and then you give it values that you want to do in a vector. And so you say, I want the third and the first elements in X. And so you do X single square bracket 3, 1, and you get the third and the first elements, right? So the third element is 3.3 and the first element is 2.1. Okay. There's a function called order, and this will give you the indexes of, or the positions of the values in X that you would need in order to put X into order if you were to run a subsetting operation. So it says, you're going to put this in from element 1, element 3, element 2, element 4 would then put X into order. Okay, so the first element is 1.1 or is 2.1. And then you're going to take the third element, which is 3.3. Then you're going to take the second element, which is 4.2, and then the fourth element, which is 5.4. Okay, and that would put this in order from least to greatest. If you give it a vector with duplicate elements in it, then you'll get the same element back multiple times. So here, if I say subset X with this vector of 1, 1, and it's going to give me this first element, 2.1, twice here. It gives me 2.1, 2.1. Okay. It's expecting integers. And so if you give it something that's not an integer, right? So here I'm giving it a vector with numbers with decimals, 2.1 and 2.9. Okay, R is going to say, I don't like that. And it's going to just silently truncate these. Okay, it's just going to say, all right, 2. And it's going to truncate these to 2. So even though it's not rounding, so it's not going to go from 2.9 to 3, it's going to just truncate it to 2, and it's going to, here it gives me back 4.2, the second element, twice. Okay. If you give it negative integers, it will remove those. Okay, it omits those elements. So here it says, give me X, but omit the third element, omit the first element. Okay, don't give me back the third and first elements. And so it gives you back 4.2 and 5.4. Okay, so it gives you X, but with those elements removed. All right. You're not allowed to mix both negative and positive values, okay, because it's ambiguous. Because here we're saying basically omit the first element, okay, sure, and give me the second element, okay, and then now R is confused and it says, what about the third and the fourth elements? Do you want those or do you not want those? Okay, because it's a little bit ambiguous, right? We're saying I don't want the first element, but give me everything else. But here, and we're saying I only want the second element. So you know, now it's confused. So it gives you an error if you try to do something like that. Here, I'm going to subset using logical values. Okay, so we're going to subset using logical values. And so I'm going to subset X using this vector of trues and falses. And when you do that, it's going to give you back the elements where it's true and omit the elements that are false. Okay, so here I got true, true, false, false. So it's going to give me back the first and second elements. It's going to omit these elements that have false. And so we can combine that with any kind of logical expression. So here I've got a logical expression, X greater than 3. All right, X greater than 3, it's going to evaluate that for these elements in X. Okay, so which elements in X are greater than 3? So it's going to be false for the first one and true, true, true for the other 3. And so basically it's going to subset X with a false, true, true, true. And so it's going to give me back 4.2, 3.3, and 5.4 here. Okay, and so this is very handy if you need to subset some kind of vector based on some kind of logical statement. So you can say, give me all the elements in X that are, you know, I don't know, divisible by 2 or divisible by 3 or something like that. You can subset X in that way. Okay, if the logical vector that you are providing to subset is shorter than the vector that's being subset, it's going to be recycled, right? So here I say subset X using true comma false, and this logical vector of true false is going to get recycled to true false true false, and that's going to correspond to returning back 2.1, not 4.2, and return 3.3, or you know, give that back and not 5.4. So we get 2.1 and 3.3, okay, because it got recycled true false true false. If you give it a logical vector, and in the logical vector you have a NA, okay, NA is going to return back, is always going to return back a missing value in NA, okay? And so here, if I do true, true, NA false, we're going to get true, true, 2.1, 4.2, and NA, and leave out the 5.4. If you, you know, the recycling rules also apply. So here I got true NA, and so this is going to go true NA, so I get 2.1 NA, 3.3 NA, and so on and so forth. Okay, so that also applies. A couple of special cases. If you subset an atomic vector with nothing, you're going to get back everything. Okay, so subsetting X with nothing inside the square braces will return the original vector X. This not necessarily useful for an atomic vector, but in a moment when we do look at matrices, it's useful there. So you might provide a row number. Say I want, you know, the first row in matrix X, but you don't specify anything for the columns, and that's going to return all of the columns. If you give it a 0, it's going to return a 0 length vector. Okay, so so here X is a type double or numeric vector, and so if you give it 0, it's going to give you back a length 0 length vector. Okay, this is not often something you do, but it's something that might happen, and sometimes you need to kind of just guard against this. So for example, you might say subset X based on some kind of condition, but that condition could end up being length 0, and then you're gonna get back a 0 length vector, and maybe that causes problems. Maybe it's okay. You kind of have to guard against things like that. These are things you need to think about. So, okay. Here, you can also, in R, you can have named vectors. So you can name the elements in your vector. And it's as simple as using names. So you can take X and you can say names of X and assign a vector there. Here I'm taking X and I'm creating a new vector Y, and I'm using the function set names. So we're going to give the names X, or we're going to set the names of vector X. The names are going to be the letters 1 through 4, so A, B, C, D, and we get Y. Okay. I think you guys are familiar with these vectors. These are kind of built-in useful vectors. So lowercase letters is the lowercase letters A through Z, and all caps letters is the character vector of capital A through Z. And so it's just very handy in case you need to kind of like name elements in a vector or a matrix or a list or something like that. If you just need to quickly name them some letters, you can do that. Okay. And so if Y is this vector, oh, and by the way, if you put parentheses around an assignment operator, so normally when you do an assignment operator, nothing gets printed out. If you put parentheses in around an assignment operator, it'll print out whatever you just assigned. Okay, so here Y is now this named vector with the values of X, but now with names A, B, C, D. And if I subset Y using the vector D, C, and A, I get the elements that correspond to D, C, and A. So no surprise there. Just like with the integer indices, if you repeat character values like A, and A, you're going to get back element A 3 times. Okay, or 2.1, which is named A, you're going to get that back 3 times. The spelling needs to be exact. Okay, spelling needs to be exact. So here I'm creating a vector Z. It's a double vector with elements 1 and 2, and they are named A, B, C, and D, E, F. And if I try to subset Z saying I want the thing named A and the thing named D, it's not going to find a match because it's expecting the spelling to be exact. So it's going to give me back NAs because the spelling is not exact. So one useful application is the creation of a lookup table. Okay, so so this seems a little bit strange, but it is actually very useful. So here I've got this vector X, okay? And it's a vector, a character vector with the letters M, F, U, F, F, M, and M. And perhaps these represent, people's genders or their gender identities. And maybe we want to say that we want to kind of turn these from just the letters M and F into the words male and female, or and maybe we'll represent you with missing, or maybe we'll, something different. And so here, notice what I'm doing. Lookup itself is a character vector, and lookup only has 3 elements in it. Okay, the elements are male, and that element is named M. Female, and that element is named F, and missing, or NA, and that element is named U. And so it's a vector of length 3, but if I quote unquote subset, if I subset the named vector of length 3 with X, which has all of these things, because we can kind of allow the indices to show up multiple times, it's going to give us back basically a vector that's of the same length as X, with kind of everything that corresponded to it using the names. Okay. And so if you want to kind of clean this up so that, you don't have these names of, M, F, and U and stuff up here, you can use this function unname, and it will return back basically where it's returned, replaced all of the X values from just single letter abbreviations to something a little bit more meaningful here. Okay. All right. Let's talk about subsetting lists. So subsetting lists is very important. Let me clear out this picture here. So lists, subsetting lists is similar to subsetting an atomic vector, except we have two subsetting operators when dealing with subsetting a list. Okay, and technically these operators also work with atomic vectors, but they're especially important when working with a list. So if you use a single square bracket, it is going to return. If you use a single square bracket with a list, it will return a list. If you use a double square bracket with a list, it will return the contents of the list element. Okay, so and the $ is also kind of a shorthand for the double square bracket. So the double square bracket is similar to the single square bracket, except it can only return a single object and allows you to pull the pieces out of a list. Okay, and it's if the list elements are named, you can use the $. If not, you have to use the double square bracket. Okay, the single square bracket will always return a list. So an analogy is that if you think of X, the list, you've got a list X as a train, okay? Then double square bracket, X double square bracket 5 is the contents, the object that's inside train car number 5. Whereas X single square bracket 4 through 6 is going to be the train of cars 4, 5, and 6, okay? So single square bracket always returns kind of the train, and the double square bracket gives you what's inside the train car. All right, so here, this is just kind of how a list will print. So here I've got list A, and the elements inside of list A are named, okay? We've got two elements. Element X is values 1 through 4. And element Y is values 9876. Okay, so I can get the contents. I can get the contents of X, or the first element, by doing A double square bracket 1, and that will give me the vector, integer vector 1 through 4. I can ask for A double square bracket Y. This is the same thing as doing A $Y, and it will give me back this integer vector 9876. Okay. If I use a single square bracket, so back here I use double square bracket. If I use a single square bracket, I can kind of give it a vector, and I can say, I want elements Y, X, and X. And when you use a single square bracket with a list, it's always going to return a list. And so here I get back a list with basically train car, or list element Y, list element X, and list element X again, because X is duplicated in this this vector here. If I try to do this with double square bracket, right? If I say A double square bracket Y X, this doesn't work. I actually get an error. I get a subscript out of bounds. Okay, so what's actually happening here? So when you do double square bracket, it's going to give you the contents of, it's going to give you back the contents of a list element. And so, it runs into trouble when we do this, okay? This is a side note. You don't have to worry about this. This double square bracket Y comma X, this vector Y comma X, it's actually equivalent to doing A double square bracket Y double square bracket X, okay? And this would work only if there's a list with an element Y, and Y itself is basically a list with an element X in it, okay? So here I have list X, list A. A is a list of 2. It contains X and it contains Y. And Y itself is a list containing X and Z, okay? And so here, if I do A double square bracket Y, then it's going to basically subset it to this list, and then double square bracket X, it's going to subset to that, and it's going to return back the character A. And this thing is equivalent to this, and this would return back the character A. But back here, where there's no X inside the Y, it doesn't work, and that's why we're going to get the subscript out of bounds here. Okay, so this is kind of a list inside of a list, or a train inside of a train, kind of like the inception of lists and trains and stuff like that. Okay, so here's an example. Here I've got a list named D, and inside list D, I've got elements I've got 3 elements and they are named A, B, and C, okay? And A is this double vector, 1, 2, 3. B is a logical vector, true, true, false, and C is a character vector, A. All right. The difference here, okay, is that I've got a single square bracket versus a double square bracket. So here I've got D single square bracket, okay? So this is going to return back the list element itself, okay? And that's going to be a list of length 1 and basically the contents, the list containing the first element, okay? And if I say, well, what is the type of D single square bracket 1? It's going to come back as a list type, okay? D double square bracket 1 returns the contents of that first list element. So it's going to give me back what's inside there, which is this double vector with the numbers 1, 2, and 3 in it. Okay, and if I ask the type of D double square bracket 1, this is going to be type double. All right. So the distinction between these, between this and this, is very important. Okay, and a lot of errors that you might encounter might be caused by the fact that maybe you used a single square bracket when you should have used a double square bracket, or you used a double square bracket when you should have used a single square bracket. Okay, so depending on what you're trying to accomplish, you need to know, do I want a list back, or do I want the thing inside the list back? Okay. All right, so here I have a list, and there's no names in it. Okay, there's no names. I've got, it's a list of length 3, and I've got an integer vector 1 through 8, a character vector, A, B, C, D, and here an integer vector 5, 4, 3, 2, 1. Okay, so this is a list, has 3 elements, but they're unnamed. And if I ask, well, what's the structure of this? It gives me back and it says it's a list of 3 elements. Okay, so if I do the single square bracket, the single square bracket is going to return, basically, if you think of this as a train of length 3, it's going to return the first train car, okay? And it's indicated because I got a double square bracket to kind of indicate that this is a list, and inside of that list is this vector 1 through 8, okay? Whereas if I do L double square bracket 1, this is the contents of that first train car, which is just this integer vector 1 through 8. Is that all right? The difference between this? And so when you, you know, a lot of times when you first get started with R, you might wonder, like, why does every single thing always have this single square bracket 1? Okay, like why does, when I do 5 plus 2, why doesn't it just say 7? Why does it always come back single square bracket 1, 7, or something like that, okay? And that is a context clue to let you know that the result is a vector, or the result is a list, or the result is something else, like a, you know, factor or something, you know. So these things that that seem mysterious at first, you know, do have a reason. And one important thing is that it allows you to distinguish between vector results and list results. Because if the result is a list, you're either going to see a double square bracket like this, or a $sign like this if it's a named list. Okay, so if you see something like this, then you've got a list. If you see something like this, you've got a list. Okay. Okay, so what's going on here? I've got L1 single square bracket 1 single square bracket 2. Okay, this comes back and it gives me back basically a list with null inside. Okay, so what's happening here is I have subset list 1 single square bracket 1, and that's basically this. And what is this? L1 single square bracket 1 is a list of 1 element. It's a list of 1 element. It's basically just the train car. Inside the train car there's 8 things in there. It's the vector with 8 in there. But this is a list of 1 element. And so when I say, give me the second element, or what's the second train car to this thing, this train of only 1 car, it gives me back and says there's no second train car. Okay, you've got nothing there. Okay, whereas over here, if I've got L1 double square bracket 1, then it says, okay, look inside. What is the contents of that first train car? Okay, oh, you got the double square bracket 1. The contents of that is this vector of length 8. Okay, it's this integer vector of length 8. And then we say, okay, well, what is the second element inside that vector of length 8? The second element there is 2. Okay, and so this works. Okay? So technically, you could do this. This is, a little bit strange. This does the recursive subsetting. And this is equivalent to doing double square bracket 1, double square bracket 2, and this would return the number 2 as well. All right, so here I've got a list inside of a list, okay? And we've got L2. L2 is a list of 3 elements. The first element is L1, which is a list of 3, okay? And the second element is this double vector numeric vector, values 10, 20, 30. And then the third element is a character vector, the letters D, E, F, G, H, I. Okay, but here I've got a list inside a list. So how do we reference this? So I want to draw a picture of this. Okay, so the way we can kind of think about this. All right. So here I've got L2. And so you can kind of think of this as, this is a list of 3. So think of this as kind of trains, and we've got 10, 20, 30. I've got a numeric vector, and here I've got D, E, F, G, H, I here, okay? And then inside L2 itself is train, is itself a list, okay? And this is going to be the values 1 through 5. The values I don't know, what do I have? A, B, C, D, A through D, and then 5 through 1. Oh, actually, this is 1 through 8. Okay, so here I've got a list inside of a list. And so if I do L2 single square bracket 1, L2 single square bracket 1, basically I am getting this entire thing, okay? This is a list of length 1. I don't know how to do this. How do I flatten this? All right, whatever. Okay, here I get this, okay? So this, L2, what is the length of L2? L2 single square bracket 1. What is its length? It's length 1, okay? This is a list of length 1. Okay, the contents of this is a list of length 3, okay? Okay, and so we see this by seeing list of length 1, okay, or this is length 1, and then the contents we've got inside of the first element, we've got 1, 2, and 3, okay? And the contents of 1, double 1 is this vector of length 8. Double 1, double 2 is this vector ABCD. Double 1, double 3 is this vector 5, 4, 3, 2, 1, okay? If I do L2, 1 and ask the structure, indeed, it says list of length 1, and then what's inside of that first element is a list of 3. Okay. Over here, if I do L2 double 1, okay, and I couldn't get this to work last time, but let's see if I can pull this off here. Okay, L2 double 1 is the contents is the contents of this first thing, and this will be a list of length 3. Okay, does that kind of make sense? The difference between L2 single square bracket 1 and L2 double square bracket 1. Okay, so L2 double square bracket 1 is going to be a list of length 3, and that's going to be this, basically this train, the train that's inside of this first train car. Okay, whereas L2 single square bracket 1 is the train car containing the train of 3, and this one is just the train of 3 inside. Okay, and so when you do the structure of L2 double 1, it's the list of 3 itself. Okay, so that's the difference between these two things. All right, and it's important that we can distinguish between these two, especially when we do I don't know, any kind of programming and stuff. You're bound to make some kind of mistake somewhere along the way, and it seems like a small and trivial thing, focusing on the difference between a single and double square bracket, but it does make a difference. Okay. Okay, so what happens? L2 double square bracket 1, 1. What is this? L2 double 1 single 1 is this thing right here. Okay. L2 double 1 single 1. Okay. Is basically this thing. Okay, it is a list. This itself is a list. Okay, that's what we get here. All right. And so if I ask for something L2 double 1 single 1 single 2 single square bracket 2 single square bracket 2, there's nothing, and so we're going to get back a null here. Okay, whereas if I do L2 double 1 double 1, okay, L2 double 1 double 1 is the where am I working here? I think is this. Okay, this is the vector itself, 1 through 8, and then okay, so double square bracket 1 double square bracket 1 is the vector of length 8 itself, and I can say, okay, well, what is the second element in this vector of length 8? And I get back this 2. All right, is this okay? I know sometimes you'll see stuff like this and it just feels so weird, right? You're just like, what are all these square brackets, right? And it's easy to get lost. It's easy to get lost in terms of like understanding a whole bunch of these square brackets. But if you understand the navigation of these square brackets, right? L2 double square bracket 1 double square bracket 1 single square bracket 2, and you can go, oh yeah, that makes sense. Here's this, and we're going to look inside that, and we're going to look inside of that, and we're going to pull out the second element that you can say, oh yeah, then the second element is going to be 2. Okay, and then whereas this doesn't work because this is a single square bracket. You know, the difference between this and this, you know, to the untrained eye is it's subtle. It's very subtle, but you know, this will probably cause errors, and this might be the thing that you want. Okay. All right. So sorry to belabor that. Let me give you your second view quiz answer for today. Second view quiz answer is D. D as in dog. D as in dog for the second view quiz answer for week 1 Friday. Okay. All right. So double square brackets, you apply it on an atomic vector. It kind of works similarly. Okay. A few subtle differences, and these aren't like super critical, but single square bracket will preserve the names. Double square bracket will drop the names. This is just kind of like one of those things like, oh, I remember this or not, you know, not a big deal. This probably won't make or break your code. However, this kind of stuff does make or break your code. Okay, if you use a single square bracket on an atomic vector and you give it an index that's out of bounds, you're going to get a missing value, right? So X is an atomic vector of length 3, and you say, give me the 5th value, and you're going to get an NA. Okay? if you try to use double square bracket and you give it an out of bounds, you get an error. Okay, and so this will kill your code. And sometimes this might be what you want. Maybe you want to kill your code at this step during the subsetting operation, or maybe you don't and you get the NA, but then later on, if you try to use this inside an if statement, right, and you say like, oh, if this element is bigger than 6 or something, you know, continue on, but then you'll run into an error at the if statement. So it kind of just depends where it's going to run into stuff. If you do a single square bracket with a 0 length anything, so whether it's the null or a integer 0 or a, you know, character 0 vector, you're going to get back a 0 length vector. Whereas if you try to do a double square bracket with nothing inside for a 0 or a null, you're going to get an error. Okay, you're attempting to select less than one element. Okay. Single versus double bracket. So here is a list. Okay, L1 is this this list of length 3, and so you're going to get similar results if you try to subset a list with single or double square brackets that are out of bounds. Okay, so if you try to subset a list with an out of bound index, it's going to give you back a null, basically a list with null inside where the contents is null. Whereas if you try to double square bracket a subset, a list with an out of bounds index, you're going to get an error. Okay, that's going to say subscript out of bounds. Subscript out of bounds is a very common error that you will encounter. All right, so a lot of times you have some kind of loop, and maybe the ends of your loop are not well defined. Maybe it's like a while loop, and you say just keep going through every single thing, and maybe you hit some kind of condition. You hit the end of a list. You're trying to subset a list according to, you know, you say subset list 1 at element I, and element I goes out of bounds. Okay. Depending on what you're doing, you'll probably run into a subscript out of bounds error. This is one of the most common errors, and you'll be able to kind of, if you. So one thing about learning R is in the beginning, all of the errors seem very cryptic, and you have no idea like what's causing your things. But as you program with R and as you gain proficiency, you're going to recognize the errors, and you're going to understand, like, the errors will actually be helpful, and you'll say like, oh, subscript out of bounds errors, I should be checking where I'm subsetting and things like that. Okay. So this is going to happen when you are subsetting, and you'll try to identify something like this. Okay. If you try to subset a list with a 0 length vector, like a null or something like that. Okay. So generally you don't intentionally try to subset a list with a null, okay, or a 0 length vector, but sometimes you'll do some kind of logical operation, and the result is going to be of length 0. Okay. So you say like, you know, tell me, you know, which x equals 5 or something, right, like that. Okay, so you say like which values of x equal something, and maybe you get like a 0 length result. Okay, and if you try to subset based on the 0 length result, okay, single subset you're going to get an empty list. Double subset you get an error. Okay, so kind of similar to these results and these kinds of things. Just you should be aware of. Okay, I got to kind of work quickly. I think we're probably going to get through about the same number of slides as the last class, and I'll just continue recording for like a supplemental video of the remaining slides I didn't get through. Okay, so a matrix is a 2-dimensional structure. Array is a higher dimensional structure, and you can subset these higher dimensional structures with multiple vectors, and that's probably the most common. Multiple vectors indicating like which rows you want to select and which columns you want to select. Okay. A matrix itself is kind of an atomic vector, and so you can subset using a single vector. And you can also subset a matrix kind of using coordinates arranged in a matrix. And so I'll show you this. All right. So here I've got a matrix, a 3x3 matrix. Here I've got 3 rows, 3 columns. The columns are named A, B, and C. And so we can first subset using a few things. So I can, if I do use a comma, it's going to say I want the first and second rows here and all of the columns, comma, nothing. So again, nothing returns everything. Okay, so this will give me the first and second rows and all of the columns. Here I can give it a logical vector, true, false, true, and this will return basically the first and third rows. Which columns do I want? I want column B and column A. Here I give it 0, which means I want none of the rows. And -2 says I don't want the second column. Okay, so this will give me, this is a matrix of 0 rows, a 0-row matrix. If there were no column names, it would be like integer 0. But because we have column names, it returns back the columns A and C without the second column here. When you subset a matrix, it by default simplifies it, okay? So here, if I subset a matrix to just the first row, right? If I say I want to subset matrix A, first row, all the columns, it's going to say, oh, you know what? I'm going to simplify that to just a vector, atomic vector of values 1, 4, 7. It does not return a 1 by 3 matrix, okay? It will simplify it down to a vector, atomic vector of length 3. That's something I think fairly unique to R. Most other languages and stuff, like in Python, if you subset an array down to like 1 row, it'll still be an array of 1 row. But here, it just simplifies it down to a vector. Okay.
I have a quick question about that output. I'm wondering why, again, I could be missing something obvious, but I'm wondering why there's not that single square bracket with the 1 in front.
It's not a single, there's no single square bracket 1 here because it's a named vector. So okay. Yeah. So if I do 1 through 3 here, I get that. And if I do x is 1 through 3, and if I do names of x, letters 1 through 3, okay? So if you have a named vector, you lose that single square bracket here. So that's all that's going on, okay? So named vectors don't have that single square bracket. Okay, but yeah, so A is a matrix, so it's not a vector. But now once you've simplified it down to the first row, it becomes a vector. Okay. Again, a matrix internally is stored as an atomic vector with just a dimension attribute. And so here I've got a character matrix, a 5 by 5 character matrix of the letters A through Y. And again, R kind of numbers these down the columns. So it's going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, so on and so forth. And you can just, without, if you don't give it, so over here I have a comma, and I want the first row, all the columns. Over here, there's no comma separating. This is just a vector here. So it just says, I want the 8th and 9th elements of the matrix. The 8th and 9th elements of the matrix is going to be H and I, and it returns back H and I here. Okay. If I put in a comma here, if I do 8, 9, comma, what would happen? So I've got vals, and I'm saying I want 8th and 9th elements here. Okay, so there returns H and I. If I put a comma after that, basically I'm asking for the 8th row and the 9th row. 8th row and 9th row. Is there an 8th row and 9th row? There is not. And so we're going to get a subscript out of bounds. So when you try to subset a matrix asking for rows that don't exist, you get a subscript out of bounds error. Okay, and the last way you can kind of subset a matrix is by giving it coordinates, right? So here, this is a 2 by 2, I mean a 5 by 5 matrix, right? So I can, if you think of this as like a chessboard or something with named rows and named columns or something like that, you can say, all right, U is in the first row, 5th column. C is in the 3rd row, 1st column. Okay, and you can reference those things and you can say, I want the element in the 1st row, 5th column. I want the element in the 3rd row, 1st column. I want the element in the 2nd row, 3rd column. I want the element in the 1st row, 1st column. And you can kind of specify like your pinpointing coordinates, and you can get values like this. So you can subset the matrix by kind of providing a set of coordinates of the elements that you want. Okay.
I have a question.
Yeah.
So you said that the matrix is internally stored as a vector, but with dimension attribute. But when we're talking about vectors, when you choose something out of bounds, it gives you an A. So why doesn't it do that for the matrix?
That it's just kind of the rules for the matrix. Yeah. So if I did this, right? So if I did vals, so here, if I ask for the 8th element in this, it's going to do this. And if I ask for like the 26th element, okay, it gives me an NA, right? But if I put in a comma and I'm basically asking for what is the 26th row, it's going to give me a subscript out of bounds. So when you put in a comma and you basically say you want this row or this column, then it gives you the subscript out of bounds. But if you treat it like an atomic vector and you say, give me the 26th element of this thing, then it gives you an NA. So that's just how it goes. All right. So all of these, like which causes errors and which returns NAs and stuff, these are just kind of internal rules, and they're just kind of like things of the language that you kind of have to learn. Or at least be aware of, so that when you encounter errors, you can kind of backtrack and solve. Okay, same kind of idea here. I've got a 3-dimensional array, okay? 2 rows, 3 columns, 2 layers. And if I wanted to pinpoint, say, element 3 and element 12 here, I can give it 3-dimensional coordinates. So this would be 1st row, 2nd column, 1st layer. 12 would be 2nd row, 3rd column, 2nd layer, okay? And so I can provide the coordinates in 3 dimensions, and I can get back those elements as well. Is that all right? Okay. Data frames. Data frames internally are stored as lists in R, okay? But they also have a 2-dimensional structure. So we can subset a data frame like we subset a list, which we spent, a good amount of time talking about. We can also subset a data frame the way we subset a matrix, okay? And so I'll show you a few examples of this. So we're going to subset the data frame like a list. We'll also subset the data frame like a matrix here. Before I go on, let me give you your last quiz answer for today. Last quiz answer for today is E as in elephant. E as in elephant. So jot that down and just make sure you take your viewing quiz sometime this weekend before Monday's lecture. So E as in elephant is your last quiz answer. Okay, so so here I've got a data frame, 4 rows, 3 columns. The columns are named X, Y, and Z, and they are stored internally as a list of 3. And the list of 3 has is named X, and the 3 elements are named X, Y, and Z. So the columns are named. The columns are basically your list elements. Okay, I've got a list of 3, each X, Y, and Z. So I can subset it kind of like a matrix. All right. And so when I subset kind of like a matrix, here I'm specifying which rows. I'm giving it a logical vector. This is a logical vector where I'm going to say, hey, I want column Y. Where is column Y mod 2 equal to 0? So where is column Y divisible by 2? Okay, and that's going to be where Y is 4 and Y is 2. So that's going to be row 1 is true, row 3 is true. And so if I do that, subsetting kind of like a matrix, the rows are true for row 1 and row 3. And so I get those rows there. Okay. If I don't put in the comma, it's going to subset like a list. Okay. So here I'm subsetting like a list, and I'm asking, give me back the list elements that are named X and Z. Okay. And so I get back this. It's a list. I'm subsetting like a list, but it's going to print back like a data frame. Okay. And so I get basically a data frame with columns X and Z. If I put in a comma, now it's like I'm subsetting like a matrix. So the end results are identical, but here I'm basically saying, give me all of the rows, okay, and the columns that are named X and Z. Okay, and so here I get back basically the same results. Okay, but there is a subtle distinction. Here I'm subsetting like it's a list. Here I'm subsetting it like a matrix. Okay, all right. I know I'm going over time. I'm going to just go for a couple more minutes, and then I'll let you guys go, and then I'll just continue recording kind of like a supplemental thing here. Okay, here I'm subsetting like a matrix. So I have a comma, to indicate which rows I want to select. So here I'm going to select rows 1 and 3, comma, all of the columns. Okay, so I know I'm subsetting with rows 1 and 3, comma, all of the columns, and that's what I get. First and third rows. If I leave out the comma, now I'm subsetting like a list. I'm saying, give me the elements in the list elements 1 and 3. List elements 1 and 3 will be basically the first column X and the third column Z. Is that okay? The distinction between 1, 3, comma, which says I want rows 1, 3, all of the columns. Here I'm subsetting like a list, and I'm saying, give me list elements 1 and 3, which will be columns, the first column and the third column. Okay. An important distinction is that if you subset like a list, okay, with a name like X here, the structure that's going to be returned is going to be a list. Okay, it's going to return as a list, and it's going to retain the structure of a data frame. If you subset like a matrix, right? So if I do df, give me X, it's going to give me back a data frame with just one column X. Here, if I do df space comma, so all of the rows, column X, this is going to get simplified into a vector. Okay, so there is a difference between when you select multiple columns. There's like with this and this, there's like almost no difference. Okay, there is no difference between selecting this columns this way and columns this way. Okay, but if you select only one, when you do it like a list, it retains the data frame list structure. If you subset it like a matrix, it's going to simplify and become a vector. Okay, subtle differences. All right. And then if you use the $sign or the double square bracket, it's much like with the list, $sign and double square bracket will simplify and just return the elements there. Okay, and so these simplify, and these just return the elements of that list or the elements of that data frame. Okay, we'll end here for now. I've gone over my time, so we'll stop the lecture and end here. And so have a good weekend, and I will see you guys on Monday. I do have office hours on Saturday, so you're welcome to that tomorrow morning at 10. I'm going to just stick around, and I'm going to just keep finishing off the lecture. I'll just record it as kind of a supplemental video if just in case people want to view that, but I'm going to go ahead and stop recording.